So I will repeat the problem because one of the problems we had a problem in connection. The screen was not sharing. So I will repeat in brief what we did last time. So we were doing problem 10. The crane is used to hoist the load. If the motors at A and B are drawing in the cable at a speed of 2 feet per second and 4 feet per second respectively, determine the speed of the load. So here we have a system of pulley with their cables, okay? And we have two motors drawing the cable in motor A and in motor B. So here we need several coordinates. First, since we have a motor, whenever you have a motor, you need one coordinate for the motor. So here, since it's drawing the cable inside, I will take the coordinate from a fixed reference towards the motor. Then this coordinate will represent the length that is going inside the motor. And I need also a coordinate for B, SB, to give me the length that is going inside motor B. And for the crane, I need, for the load, I need a coordinate. So I will take this coordinate for the load, okay? And I will name my coordinates as S of A, S of B, and for load, I will call it C. So this is S of C, okay? Now, if I want to find the total length of the cord, I will express it function of my coordinates, and I will lump all constants in one term, okay? So for the length inside that is rolling in the motor, and this part, this is SA. So first I will write SA plus I have this part is a constant, so I will keep it with the constants. This is SC, okay? This is a constant. This is SC a second time, so here I have plus 2SC. And concerning this part, this is a constant. And since here I have SC again, this is a constant, and SC a fourth time, so here I will update the coefficient. It is plus 4SC. Okay. And this part here is a constant. And finally, I have this length plus what is going inside the motor. This is SB. So plus SB equals to a constant. Okay. Now, once I derive this relation, I can get a relation between velocities and a relation between displacement. Okay. Because as we have seen last time, you know that if you derive this relation, what do we get? Let us see the equation here. So first, as we said, we put the coordinate system. Then we write the total. This is the total length. Okay. Here they just added 2h, and then you take it to the other side. It will give you a constant. Then this is from the total length of the cord. This relation. Okay. Now we will derive this relation with respect to time. When I derive velocity with respect to time, when I derive position with respect to time, I will get velocity. Okay. So I have 4vc plus va plus vb. The derivative of constant is 0. So this is equal to 0. Now, what I know in this problem, okay, I know that va is 2 and vb is 4. So I can get the value of VC. Okay. I think maybe this is, we already did this. The problem was with this one. Okay. Yeah. So let us repeat this one.
دكتور
So if motors at A
شمت
and B
شمت
draw their
السكرين عندي.
attached cable with an acceleration of 0.2 t, where t is in seconds, determine the speed of the block when it will reach a height of 4 meters starting from rest at h equals 0. Also, how much time does it take to reach this height? So here it's a little bit similar to the previous example, but more complicated. So what do we have here? First, we have two motors drawing their cable in the motor. So you need for each motor a coordinate. So let us consider this is the datum. So we need datum is reference line, okay, which would pass by fixed point. So I can consider that this coordinate is for motor A. This is SA. I have for B, I need also a coordinate. So let's say this is SB. And if you want also, instead of taking the datum here, you can take it. It's more convenient maybe to take it here. Okay. Anyway, the difference is a constant, so it will not affect the result, because when you derive, this constant will be simplified. So I will call this constant H here, and I will consider that this is my reference. Okay. So now for pulley D, okay, the center of pulley D is attached to the periphery of a moving pulley, so it's not fixed. Then I need a coordinate for D, so I will take S of D, okay. And I have for pulley C, the center of pulley C is attached to a block that is moving, so the block and pulley C, the center of C, will move together. So I just need to take S of C like this, okay. So until now, I have S of A. I have, if you have any question, put it in the chat. When I finish the problem, I will go back to your questions, okay? So this is SA, this is SB.
يا دكتور أصلا مش مقشوع على السكرين عندك.
And this is F of D.
Vegan, how is?
So now, I will write the total length of the chords. I will start with this chord, okay? You have from this point to this one, this is SA. And this is a constant, so SA plus constant. I will just put SA because I will add all constants together. So this is SA. Here I have a constant part, so I will keep it with the constant. Here it's H also. Plus what? Plus this part. This part is SD. Now I have a constant here, and again I have SD. Okay, so it's 2 SD plus a constant here.
Vegan.
So the first equation is SA plus 2 SD equals to constant. Okay, and I will do the same job for the second chord. So for the second chord, I can start from this point, okay, from here. This length is S of C minus S of D, okay, because look, this part here is this distance, which is SC minus this one, okay. So this part is SC minus SD, while this part, when you go here, SC. So I have until now 2 SC minus SD. So 2 SC minus S of D. And I have here, if I continue, I have S of B. Okay, so it's 2 SC minus SD plus SB equals to a constant. Okay, now also here I will derive these two relations to get a relation between velocities. And also in this problem, they gave me something about displacement. Okay, this is why I need to find a correlation for delta S, because look, they told me that initially at the floor level, and then it will rise upward to a certain level. So here I know the value of delta SC. Okay, and since the block is rising and SC is downward, then I know that delta SC is negative and delta SC is -4. Because I know the value of delta SC, I will try to relate delta S in order to find delta for other components. Okay. So here, when you derive this relation with respect to time, you will get relation between instantaneous velocities. Okay. And since if the relation apply for instantaneous velocity, then it will also apply for average velocity. Okay, because at each instant it is valid. So of course it's average on an average base. The opposite is not right. If you have a relation between average velocities, you cannot say that it will apply for instantaneous velocities. But if it's applying for instantaneous velocities, then of course it will apply for average velocities. And we know that V average is delta S over delta T. So I can say that the relation between velocities will also apply for delta S because if you eliminate delta T, which is the same for all, you will get mean the
مش
delta S.
هيبينوا عندك.
Okay? Let us see together what are these relations.
لا انت ما معلقه الشاشه بس هي بتطلع على الشاشه مبلا.
هي بتطلع بس على شاشتنا يعني قدامك بتطلع بس قدامه ما بتطلع.
So first, as we said, the first step is to write the total length of each chord. So here we have the first chord, it's SA plus 2SC.
ليك انا ما عندي سكرين
The
حتى
second
انت
chord
عندكم سكرين.
is 2SC minus SD plus SB.
لكن
Now, if we derive the two relations with respect to time and then replace, if we get instead of V average delta S over delta T, you will get that delta SA is minus 2 delta ST. And from the second relation, 2 delta SC minus delta SD plus delta SB equals to 0. Now, we know one of these. We know that delta SC is -4. Another information that we know is that the acceleration of motor A from given acceleration of motor A is 0.2 t. Okay, and also they give us that it's equal to acceleration of motor B. So since the system is we have the system starting from rest, okay, and we have that acceleration is equal for A and B equal to 0.2 t. So we can say that also delta S will be equal. Okay, so we can say that delta S of A will be equal to delta S of B. Since we have same conditions for motors A and B. So this equation will add to our system. Okay, so now what do I know? I know delta SC. I know a relation between delta SA and delta SB. So now if I replace delta SC by its value and I replace delta SA by delta SB, then I can get two equations with two unknowns. This is the first one, and this is the second one. Then I can calculate all my unknowns here. Okay, so this will allow me to determine the value of delta SA, delta SB, and delta ST. Okay, now in the next step, I have that what I need to find is the time needed to reach this position. Yani, I calculated all delta S because it will help me in calculation of time. Okay, because I know the acceleration of A and B, and I know delta S, so I can get time if I find delta S function of time. To find delta S function of time, I should do the integration procedure. So I know that A is dV by dt. So to get an expression for velocity, I should integrate first this equation with respect to time. I will get V then. Okay? And another integration will be needed to get F. Now, since I have boundary conditions, because I know that the system is starting from rest, so V will be equal to 0.1 so 0.1 t cube over c. So let us see the details of integration here.
شو بين راح الصوت هلا.
So as we said, we have a, or you can do the integration for constant, and then from boundary condition, you replace V0 by 0. So you will get V equals 0.1 t squared. Then you say that V is ds over dt. You can do separation of variables, or you can directly do integration because it's simple here. And then you get the delta S is 0.1 t cube over c. And since you know that delta S of A and delta S of B are already calculated equal to 5.33, this equation will allow you to calculate the time needed for this operation. And also they asked for what will be the velocity of the block at this instant. So by replacing in V, you will get here in 0.1 t squared, you will get VA and VB. But since we are interested in VC, you can go back to your relations of velocities, okay, from the system of two equations for velocities, and then this will allow you to calculate the value of VC. Okay, you will get a negative result, of course, because block C is going up while your coordinate is positive down. Okay. Any question on this? I will now check your chat. So please, if you have any question, just tell me.
يعني
شايفين الميات بالداينامكس؟ احلموا فيها انا بقولكم من هلا.
Guys,
ايش يا عم بتيجي push.
now you don't see the screen.
Yes.
At what time did the screen?
نص ساعة.
Long time ago you don't see the screen.
Yes.
Can you tell me from which instant the screen disappeared for you?
ليكو حدا صور سكرين.
بالأول
صوروا.
first.
طب okay, I will repeat. What was I was
حدا قال لنا بعد ما شفناها حتى.
قولوا لها زوم.
I don't know why this is happening in Teams. It is happening with you in other courses or just in this course? Look, I will. Do someone of you have my phone number? You can call me when this will happen another time.
قال دقيت لك ما تركت حدا ما دق لك.
Please, if someone, if the representing student of you have my number, when this happen, direct me, tell me. So I will keep my phone next to me. I will bring it. Then you can tell me when you have a problem. Just 1 second. So I will bring it.
شو بدكم قلها؟ فيلج
فيجن.
لا فيجن حول
لا فيجن اوت. لايكو بدنا نقلق انه تعمل تشيل السكرين ترجع تحطها، تعمل شيء مره ثانيه.
مش احسن عزوم اسالها.
Paul bro شو كتبت؟ There are some students that don't have a screen.
بكتب لك ايه بالفرنش؟
Okay, look, my phone is with me now. So when it will happen again, directly tell me. I will go to re-explain. So I was explaining the coordinates when it happened.
بس بعد ما عم نشوف السكرين.
ايه ما هيك معنا. جوي وينك عم تحكيها؟
ما غيرت شيء.
يا اخي شو؟ اعطوها لحظة عم تعملوا شيء سكرين
جو كولر.
بلاش تشالها. طول بالك.
Do you see it now? Do you see the screen now?
شو بلا؟
Yes, we can see it.
Please, the student who has my number, can you reply on WhatsApp, please?
يلا جو. مسألة كمان بعدين يا دكتور.
يلا جو.
Okay. Yeah. So I will re-explain. Okay. So here we said that we have two cables, okay? And we need to find the time needed to have the block up, okay? So in this case, the first step to do is to write the total length of the two cords. This is the first cord here. Last time we have done this in detail, but I will repeat in brief. So you need one coordinate for A, one coordinate for D, one coordinate for C. C is attached to the block, so they will move together, and one coordinate for motor B. This is the first cord if you follow the mouse. So this is from here to here, you have SA. This is a constant, this is a constant. And also this part is constant. So just I have to do first SA plus this part here is SD. So until now I have SD. Then I have a constant, and this part is SD plus constant. So in total for my first chord, which extends from motor A to the ceiling level here, the total length is SA plus 2SD equals to a constant. Okay? Then I will repeat this for the second chord. For the second chord, starting from here, this distance is SC minus SD, because this part is the whole part, which is SC, minus this part, which is S of T. So I have this length is SC minus SD plus this part, which is S of C. So until now, I have 2 SC minus SD, then I have a constant, then I have SB. So in total, 2SC minus SD plus SB equals to a constant. Now I will derive these two relations, okay? When I derive the two relations, I will get a relation between velocities and a relation between displacement, because this equation will give me that VA plus 2VD equals to 0, and delta SA plus 2 delta SD equals to 0. The same, the second equation can give me two equations. Let me check one thing. طيب. الو
دكتور ما في مش عشان الشاشة.
طب يلا جو. اوكي يلا. I will share again. Do you see it again now? Joe, do you see it again now? Okay. So this is the second chord. Okay. From the second chord, if we derive this relation, we will get 2VC minus D plus VB equals to 0. And for displacement, we get 2 delta SC minus delta SD plus delta SB equals to 0. Okay. Now, in the next step, once I get these relations, I will use what I know. They told me that the block will rise up a distance of 4 meters. So initially, my block was at the ground level, okay? And by operating my motors, the block will be lifted upward a distance of 4 meters. Since it's lifted up and SC is downward, okay, then delta SC will be negative. So delta SC is equal to minus 4, okay? And they told me that the two motors are operating from rest at same acceleration. This is why, since AA is equal to AB and we have both starting from rest, we have that delta SA will be equal to delta SB, okay? Now, By replacing delta SC in the equation number 2, and by replacing delta SA by delta SB in the two equations, then we will end up with two equations with two unknowns. We can get the values of delta SA and delta SD. So once we solve for all delta S, then we can go to the second step in order to get the time needed to do this operation. Okay? You know that acceleration of A equal acceleration of B equals to 0.2 t. If you integrate this relation, you can get the equation of velocity, because you know that V is integral of A dt. So you get V is 0.1 t squared plus V0. Since it's starting from rest, V0 is equal to 0. Now, once we have the expression of velocity, we can integrate this relation again to get the position with respect to time. So if we integrate this relation, considering that S is 0 when t equal to 0, you get that S equal to 0.1 t cube over 3, which is equal to 5.33, which we calculated in the previous step. So now, this equation will allow you to calculate the time needed to lift the block 4 meters. And also, they want you to find the velocity of the block at this instant. So after finding the time t, you insert the time into the equation V equals 0.1 t squared. Just pay attention, this is V of A or V of B. So once you find VA and VB, in order to calculate VC, you will go back to your system for velocities. The system for velocities will give you that by replacing VA and VB by their values, you will end up with two unknowns, which are VC and VD. So the solution of this system will give you what will be the velocity of block C at this instant. Okay? Block and what will be its velocity. And also, as expected, we will get a negative result for VC because the block is rising upward, while V is positive downward, since SC is positive downward. Okay? Any question on this problem? So let me check your chats to see if you need anything. Okay. Mark, concerning, I am giving, because I'm giving several online lectures and I'm using Zoom, for example, it's not happening. This is not happening with me. So I don't know what is the problem. Anyway, I will check it after. Now, do you have any questions for this problem before we move to another one? Okay, so I will start with another one. Okay, I will start with another problem. So now I switched to the screen. Do you still see the screen? Joe, please just tell me if you see it now. Okay. So a car A travels along a straight road at a speed of 25 meters per second, while accelerating at 1.5 meter per second square. At this time, at the same instant, car C is traveling along the straight road with a speed of 30 meters per second, while decelerating at 3 meters per second square. Determine the velocity and acceleration of car A relative to car C, and the velocity and acceleration of car B relative to car C. Okay, so here we have two cars. One is traveling on a straight road, while the other is going over a curved path. And we want to find what is the, we have here three cars, A, B, and C. Okay, we want to determine the velocity and acceleration of A relative to C, and the velocity and acceleration of B relative to C. So first, let us find the velocity and acceleration of each of the cars. Then, to calculate velocity of A, for example, relative to C, all we have to do is to do V of A minus V of C. The same for acceleration relation, and we will repeat the same calculation for car B. Okay, so now we should find for each car what is the absolute velocity and absolute acceleration. When I talk about absolute velocity and acceleration, this means that I am calculating them in a fixed frame. Okay, so if I consider a fixed frame ij, so this is I, and this is j. Okay, now what I will do is that I will find the velocity and acceleration of each of the cars. So first, for car C, okay, I have the velocity is directed along minus j. Okay, so for VC I have minus 30j. So VC is equal to minus 30 along j. Now, for acceleration of C, it is positive along j. Okay, so as you can see here, AC is plus 3j. So for AC, it's plus 3j. Now, concerning car A. For car A, okay, it is, look, it is going over a straight line, if you want. It's not curved, but it's a line, but that is inclined. Okay, so it's doing translation on an inclined line. The inclined line is doing an angle of 45 degrees with the horizontal. So the velocity and the acceleration both should be decomposed into ij components. Okay, all we have to do, and since they are downward, both are downward, so they will have both negative I and negative j. So I just have to decompose into I and j. So for VA, it will be minus 25 cosine 45i and minus 25 sine 45j, while for the acceleration, it will be minus 1.5 cosine 45i and minus 1.5 sine 45j. Still, I should find velocity and acceleration of B. So for B, it is a little bit more complex because it's a rotation. So here I have a curved path. So I should pay attention that in case of rotation, the acceleration should be divided into two components, normal and tangential. Okay, so let me, if you want, for B, I will draw it here again. So B is moving on a curved path, and they gave me that this path has a radius of 100 meters, and at this instant the radius is doing an angle of 30 degrees with the horizontal line. This will help me to determine the directions of UN UT, because you know that in a circular path, UN is directed towards the center of rotation. So this is UN. And UT is tangent to the path. Okay, so a UT axis will be downward because B is moving, the velocity is down, while the acceleration, the tangential acceleration, okay, while the tangential acceleration is upward. Okay, so because the tangential acceleration is upward, this means that we have a decreased velocity. Okay, so here we have, this is un, and this is ut. Okay, so now we should decompose un ut on I and j to be able to find the expression of an at in ij in terms of ij, because you know that first for the velocity is along ut, so you can say that v vector, the velocity vector, is equal to the velocity magnitude times ut. Okay, but since I want to express in I and j, I should decompose ut into ij components. Okay, so to decompose ut into ij, I should know the angle it's doing with the horizontal or the vertical. So if you look back to your figure here, okay, un is doing 30 degrees with the horizontal. This means that ut will do with the horizontal an angle of 60 degrees, because un and ut are perpendicular. Okay, so here it's a 90 degrees angle between un and ut. So if I extend the line of action of ut, okay, yalla, I will share again 1 second. I'm really sorry. I will talk to Dr. Rani to switch to Zoom. He told us that in general it's not allowed to switch to Zoom, but we are facing a lot of issues. So if this is not fixed, we will continue our sessions on Zoom. Okay.
Okay, doctor.
Do you see now the screen again?
Yes.
Joe, do you see it now? Okay. Okay. So here, as you can see, the ut vector is downward, like the velocity. Okay. So it's represented here. It's tangent to the path downward. And as I said, un is doing an angle of 30 degrees with the horizontal. So ut is, if I extend the line of action of ut, okay, it will do an angle of 60 degrees with this, because you are circular.
حكت معي شيء؟
Here,
عم تسمعوها؟
okay,
لا
plus
الصوت
sine 60j. Now, if I replace ut by its components along I and j, I will obtain v decomposed into ij components. Now, concerning acceleration, acceleration of b has two components. Tangential one, which is along minus ut, because it's along minus ut, so it will be like this. It will have an angle of 30 degrees with j and 60 degrees with I. So if you want to decompose it, then you will just write minus 2 times ut and replace ut by its expression, which is cosine 60i minus sine 60j, because ut is down. Okay. Now, I still have the normal acceleration. The normal acceleration is directed towards of rotation, so it's along un. And we know that the normal acceleration in magnitude is given by what? So an in magnitude is given by v squared over rho. Okay, so an is v squared over rho in magnitude. And since the direction as is along un, I will decompose it into I and j component. So it's cosine 30, un is cosine 30i plus sine 30j. Okay, I will repeat everything in the calculation here. So the first step, as we said, is to determine the components of all velocities. So first for A, as we said, A is doing translation on a inclined line. And since the inclined line is doing an angle of 45 with the horizontal, then this is the direction of velocity. Okay, it will have negative I, negative j. So this expression will be for VA minus 25 cosine 5i minus 25 sine 45j. Now for VC, it's just along minus j, so VC equal to minus 30j. And in order to calculate the relative velocity, we just have to apply the relation that VA is equal to VC plus velocity of A with respect to C. So this will give you that velocity of A minus VC. Okay. Now, this will the magnitude of this vector is given by rad
عم تسمعوا؟
لا انا رايح السكرين كمان.
Do you hear me now? Do you hear me now? Okay. Yeah. Look, when I finish this problem, we will switch to Zoom, okay? Yeah, just because, let me finish it and we switch to Zoom. Because it's very bad here. Okay. So do you see the screen now, Joe? Okay. Yeah. So we have for the magnitude, it is radical, as we said. Now concerning the direction, it's a negative component along I, positive component along J. So it will be like this. Okay. This is the vector. And in this case, I can find the angle with the horizontal here. Here's the angle theta with the horizontal as tangent minus 1 of the y component of the absolute value of y component over x component. Okay, because this length is 1232 and this length is 17.68. So the angle theta will be tangent minus 1 of 12.32 over 17.68. Okay. Now, after this, I will calculate now the relative acceleration. Okay. So as the first step for the acceleration, I get acceleration of A and acceleration of C. As we said, both are doing translation, but A is translating on a inclined line. So AA will be along this inclined line, and since it's downward, so it is minus 1.5 cosine 45i, minus 1.5 sine 45j, while for acceleration of C, it's along positive j, so it's 3j. Now all I have to do is to replace into the vectorial relation to get the relative acceleration, and also the same for the magnitude and direction. Now finally, concerning relative velocity and acceleration of b with respect to c, here for velocity, as we did together, it's along ut, and ut vector is cosine 60i minus 60j. Yeah, just 1 second. I'm sharing again. Do you see the screen now? Yalla, we will finish this problem and switch to Zoom. Do you see the screen now? Joe, do you see it now? Okay. So this is the velocity of B. Concerning velocity of point C, it is already calculated. So we can calculate VB relative to C. Just we still have acceleration of B relative to acceleration of C. And here we, as we said, we should pay attention that A is moving on a curve. So A will be decomposed into tangential and normal acceleration. The magnitude of the normal acceleration is given by v square over rho. And concerning the decomposition, we have AB tangential is along ut, but negative ut because it's opposing the velocity. This is why AB tangential is minus 2 ut, and since ut is minus cos, it is cosine 60 minus sine 60, cosine 60 along I minus sine 60 along j. Then AB tangential will be minus 2 cosine 60 plus 2 cosine 60 along I plus 2 sine 60 along j. While for the normal component is directed towards un, and un is doing an angle of 30 degrees with the horizontal. So it an has positive I and j components. And to decompose on I do magnitude of an cosine 30. So I have 2.25 cosine 30 along I and plus 2.25 sine 30 along j. Then I get the vector AB normal. And finally, once I have AB tangential and AB normal, I add both to get the total acceleration of point B. And now I will be ready to calculate the relative acceleration of B with respect to C by doing AB minus AC. Okay, so this was the last problem for review on chapter 12. Okay, I will give you an assignment on 12 to practice more during the vacation. And now we will start a new problem, a new chapter. So this is why I will send you now a link, okay, a Zoom link. Let me send it to you to open a new session, okay? Just 1 minute to send you the link. I will put the link in the chat, okay? So you can join the Zoom link. And also, please tell your friends, maybe some of your friends left because of the bad connection. Give the link, if you have a group for the class, send the link so everyone who wants can join. Yeah, just 1 minute. This is a permanent link, okay, but the problem is that it is limited to 40 minutes, so I will send you the link. And I will use the recording
اذا بدكم تظهروا ببعث لكم اللينك على على الواتساب.
ماشي يلا. فيجن حول.
فيجن
فيجن يلا.
فيجن نام.
3 2 1 جندوا.
فيجن حول.
فول اقوى واحد.
فيجن اوت.
فيجن اوت.